Aloha from Hawaii. Uh, Wish you could be here on this sunny tropical island with me, but hopefully you're enjoying the nice weather back in Ohio, or I guess wherever you are. Some of you guys may have uh, quarantined yourself on a remote island just like myself. So wherever you are, hopefully you're safe. Hopefully you're doing well. You're staying happy. Definitely miss you guys. Now that the official statement has come out that we are doing this for the rest of the school year, it just makes us miss you that much more. So again, hopefully we get to have some sort of contact with you. Those of you guys that have jumped on to our office hours or emailed us, just reading those emails lifts our spirits, and we love just chatting with you guys. So if you haven't gotten onto those, please jump on, just say hi. We love to see your faces, hear your voices. We definitely miss that. It's kind of crazy how it's already been over, 6 weeks since we've last seen you all in school. Can't wait to be back. Hopefully we're back in the fall. Who knows what's going to happen, but no matter what happens, hopefully you guys are in good spirits and keeping up with us and ready to hit the home stretch, right? We have 4 weeks left here, and hopefully you guys are ready to get to quote unquote summer if you're not already there. So anyways, before we jump into our new material, new week, new riddle. That was weird. Anyways, all right, so first one, which one should I do? I like this one. What invention lets you look right through a wall? What invention lets you look right through a wall? Think about it. And answers in 3, 2, 1. A window. I cracked up when I read that one. I don't know why. Anyways, this one's sort of related to what we're going through. A girl who was just learning to drive went down a one-way street in the wrong direction. Be honest, how many of you have done that before? But anyways, she didn't break the law. How come? Too easy. She was walking. You're allowed to walk whichever way you want. Yeah. All right, last one. A red house is made from red bricks. A blue house is made from blue bricks. A yellow house made from yellow bricks. What is a greenhouse made from? And 3, 2, 1. A greenhouse is made from glass. You silly. It can't be made from bricks. It wouldn't work. All right. Anyways, hopefully that entertained you. I don't know. It entertained me. But we are actually done with our circles. I know some of you guys were getting a little tired of circles. We've been spending 4 weeks now. Hopefully you've been spending 4 weeks, but 4 weeks and now we're done. Okay, so we're setting circles aside, moving on to our last unit. Like I said, our home stretch of the rest of the year here, which is three-dimensional modeling. Okay, so we're getting into our 3D shapes. It's hard to visualize that without having something in front of you, but we will do our best. So let's take a look here at our notes. Okay, so week 5, three-dimensional modeling. Okay, what are we talking about when we talk 3D? Okay, well, in this week, our goals here are determine the surface area of prisms and cylinders, determine the surface area of pyramids and cones, and then determine the surface area of spheres. Now, if you see a common link between all of those, surface area, surface area, surface area. So the first thing that we're starting off here for our 3D stuff is surface area. Now, area is a two-dimensional measurement. Okay, but it applies to our three-dimensional objects. So to get into that, we first need to think about, okay, why do we care about 3D modeling, right? Why do we care about 3D objects at all? Well, obvious answers. We have real world is 3D, right? We have all these objects in real life that are three-dimensional. They have length, width, and height, or any three dimensions that you can think of. And we can represent all of those objects as these 3D objects that we talk about. So cubes, rectangular prisms, spheres, cones, cylinders, to say the least. There are a lot more. Right? But really, where we want to go with that is we have even more complex objects, right? Of course, we have a rectangular prism, we have a box. We could talk about a box, but we want to go further. We want to say, okay, what if I put those together, right? And then I have what we see here in this farm. We see a bunch of different 3D objects that we can model with the 3D objects that we are going to talk about. Right. In a normal year, we do what we call the farm project. If you ask anybody that's taken geometry before at Kaufman, they will remember this farm project. It's a very involved problem and project that a lot of kids get into. Unfortunately, we're not going to be able to do that this year, but we can talk about it because we have a barn, we have silos. As we go along with this video today, think about what shapes you see in this picture. Okay. Now, ultimately, what we want to be able to do, okay, those of you guys that are interested in like engineering and that sort of stuff, we could put all those objects together and come up with a very complex model of something. If you look in here, you have a bunch of different shapes. You put them together, and you can get very creative with it. So we want to be able to model that because then we know, okay, how much material do we need? How much paint do we need? Okay, how much space is this building going to take up? So that's why we want 3D modeling. Now, to get there, we wanted to talk about 5 basic three-dimensional figures, what we call solids. Okay, we call them solids because they're three-dimensional. They're solid. It's not just a flat surface in this case. Okay. So we have prisms, cylinders, pyramids, cones, and spheres. In this first video, we're going to talk about prisms and cylinders. If you look at those, maybe you can start to see some similarities between them. Okay. In the second video, we're going to talk about the pyramids, cones, and spheres. Okay. So focusing on prisms and cylinders, these are some examples. Okay, just looking at these, just think about what you see. Okay, I'm going to show you a video here in 1 second to kind of explain what these are a little more in depth, but hopefully you can start to see these. So, saying that, let's go ahead and take a look at this video here. Okay, so, where'd it go? So, if we have a rectangle, and we extend it along that third dimension, it becomes a rectangular prism. If we have a triangle and we extend it along that third dimension, then we have what we call a triangular prism. Okay? If we have a circle, we could do the same thing, extend it along that third dimension. That is what we call a cylinder. Now, based off of those last two, you might have thought that would be called a circular prism, but a prism is made from extending a polygon. And since a circle is not a polygon, well, this is not a prism. Okay, so those are some basic examples of what we're going to talk about, prisms and cylinders. Now, if you notice here, okay, each of these started from a 2D object, a rectangle, a triangle, a circle, and then extended along that third dimension. So it's the same object every single point along the way. Okay, so if we go back to our notes here, if you take a look at these guys, notice the front and the back, quote unquote, or in this case, the top and the bottom, it's the same exact shape because we're taking that two-dimensional shape. In this case, we have this triangle and we're extending it. Okay, so we're putting infinite amounts of triangles there to get to this back triangle. As we start to calculate these, we will refer to those as the bases of these three-dimensional objects, these prisms, these cylinders. So each of these objects, they have what we call a base, and they actually have 2 bases. So if you notice here, we have this pentagon. It's the same in front as in the back. Here we have a what is it? 1, 2, 3, 4, 5, 6, a hexagon, and it's the same on the back as well. Okay, same thing with our cylinders. We just have a base as a circle, and it's extended all the way to the other side. So we have two bases, and then what we call the sides of your prisms and cylinders. Okay, so now that we know what those 3D objects are, what prisms and cylinders are, first thing we're going to talk about with those is what we call the surface area. Okay. Now you've calculated surface area. This is actually, I believe, a middle school standard. So hopefully you've actually done this before. This is just a refresher. But the surface area is the total area, which is a two-dimensional measurement, of the surface of a three-dimensional object. So we're talking the two-dimensional measurement of a three-dimensional object, the area. Okay. A simple way of thinking about this is the amount of paint or the amount of wrapping paper you would need to wrap each of these objects. Okay. Now, you've probably seen these types of pictures before. These guys down here, these are what we call nets. Okay. Now you're probably thinking to yourself, well, that net is, if I took this 3D object and I unfolded it, well, then it would become this two-dimensional object. Okay. Same thing with this pyramid. If I unfolded that, it would become a two-dimensional object. That is what we call a net. Now, what is a net useful for? A net makes it a 2D object, so then I could calculate the area of that three-dimensional object. Okay, so that's where these nets come in handy. They allow us to calculate what we call the surface area. All right, so now, like I said, first thing we want to focus on is the surface area of prisms. Okay, remember those are, if I take a 2D object or a 2D polygon and I extend it along that third dimension, it creates a solid where we have two bases and then the sides. Now, for simplicity's sake, we're going to be talking about what we call right prisms. Okay, what that means is these are standing straight up and down, or they're laying flat on the ground. Okay, so the sides are perpendicular to the bases. Okay, we could have prisms that are slanted, and those are a little trickier to calculate. So just for simplicity's sake, we're talking right prisms. So when we refer to a prism, that's what we're talking about. Okay, now if you see here, okay, I took this, what we call a rectangular prism. Okay, so this is a rectangular prism. Now, why would I call it a rectangular prism? Well, if I look at the base here, okay, so the base is up here, that is a rectangle. Okay, it could be a square, but we know that's at least a rectangle. And I extended it along that third dimension to get to another base, and so that's why we call it a prism. Okay, well, if I unfold that, well, then I have my base here, I have my base here, and then my sides for these four sections. Okay, same thing down here. This is, if up here was a rectangular prism, down here, if the base is a triangle, well, we would call that a triangular prism. Okay, because the two bases are triangles, and then we extend those, and then we have those sides. Okay, so we have a base here and a base here. Now, one thing that you will notice, and hopefully you can kind of visualize here, we know this is a prism because when I do unfold it, okay, the sides that are not bases, okay, what shape are those? So this guy, this guy, this guy, this guy, this guy, this guy, this guy. If we have right prisms, the sides are always going to be rectangles. Okay, so keep that in mind. Some people get these confused and they're not sure if it's a prism or not. Well, if you look at the sides and they're all rectangles, then I know it's a prism. Okay, which, because they're all rectangles, that makes calculating the surface area fairly easy, because we know the area of a rectangle is just length times width. So we can easily get those surfaces. Okay, so now if I want to talk about the surface area of these prisms, okay, essentially what we're doing is we're going to take the area of, all of these faces. So I want the area of that base, the area of that base, the area of that side, that side, that side, that side, and just calculate that, add them all up. Really, it's as simple as that. Okay, I don't want you to overthink it. We know how to find the area of a rectangle. Boom, there it is. Okay, same thing with a triangular prism. Okay, I'm going to find the area of the sides, which are rectangles, and then the area of the triangles, which, if you remember, is 1/2 base times height. Okay, so I think we all have the capability of finding the surface areas. Now, what we want to kind of extend from what you did back in middle school is there maybe an easier way or a more efficient way of calculating that surface area? Okay, well, if you notice, excuse me there, okay, for our rectangular prism, okay, that top part is a base, the bottom part is a base. What do we know about those two bases? Well, they're exactly identical. They're congruent to each other. Okay. So I'm going to find the area of one of those and I'm just going to double it. So if I want to find the surface area, we'll represent with S. Then I take 2 times capital B. Now, keep in mind, and I'll write a little note down here. Okay, capital B is the area of the base. Okay, we're going to be referring to capital B a lot in this 3D unit. So know that the capital B talks about the area of the base, opposed to if we talk about lowercase b, that is just the length of a side. Okay, we've used that in the calculation of rectangles, triangles, and so on and so forth. Okay, so we have 2 times the base. Now, if I take a look, I want the area of this guy. Now, if you notice, that is essentially just another rectangle, right? It's just a rectangle composed of 4 other rectangles. Now, the height of this rectangle is really the height of this prism, right? Now, if you think about the quote unquote length of this rectangle, okay, so that bottom side, well, where does that come from? Well, if I unfolded this rectangular prism, that came from those sides. I'm going to highlight this a little better. Okay, so it's just the outside of that base. Well, what do we call the outside of a shape? We call that the perimeter. Okay, so I'm taking the perimeter, and so that pink highlight is capital P, the perimeter of the base. Okay, so capital B, let's say that is the perimeter of the base. Okay, so then if I want the area of that rectangle, then I'm adding the perimeter times the height. Okay, so I'm going to take that equation, and that's going to work for any prism, no matter if it's a triangular prism, a rectangular prism, a hexagonal prism. Okay, we're going to stick to rectangles and triangles just because it's easier to calculate that capital B, that area of the base. If we get into hexagons, it's a little more involved. I think for our situation, we're going to leave those out. Okay, so let's take that and apply that. So I have these 2 prisms. I have a rectangular prism, I have a triangular prism. So I want to find the surface area of each of those. Okay, now again, I could just unfold these. I could look at, well, this front face, right? I have an 8 by 12. I could multiply those, multiply for the other sides, add those all up, boom, I'm done. Okay, if you want to do that, by all means, go ahead and do that. I think that works. Okay, but we're going to take a look to see if I can use that equation. Remember, the surface area is equal to 2 times the area of the base plus the perimeter times the height. Okay, some teachers will swear by that equation. Again, if you've paid attention at all this year, I am not picky on if you use the equation or not. I want you to use your own thinking. Okay, if it makes more sense just to unfold this and calculate the area of each side, add those all up, by all means do that. Okay, but I'm going to go ahead and try to use this equation. So if I, for this rectangular prism, first thing I need to do is determine which of these is our base. Okay, since they're all rectangles, okay, I could pick any side. I'm going to talk about the top and the bottom as our base. Okay, so if I want the area of the base, well, I know that's 8 by 6. So my surface area is 2 times 8 by 6. So that takes care of my bases. Now I need the sides. Okay, the sides, that is what we call the lateral area. Okay, that is what we're calculating here. So the lateral area is the perimeter times the height. So let's figure out that lateral area. Okay, well, I'm taking the perimeter, which is 8 plus 6, but we also know 8 and 6. So if I add those up, then I end up with 28. And then I want times the height, which is 12. Okay. So then I multiply these out. I have 2 times 8 times 6, which is 96, plus 28 times 12 gives us 336. Add those up. 96 plus 336 gives me 432. Okay, now let's think about what our unit here is. Well, these were in centimeters. Now remember, this is area, so it's centimeters squared. Okay, when you take your assessment on Alex, I believe it's going to be picky, and you need to know, okay, area is always that unit squared. Okay, all right, so that was our rectangular prism. Now I'm taking a look at this triangular prism. Okay, triangular prism, because the base is what shape? Hopefully you said it, a triangle. Okay, so again, when we're calculating for this capital B, this area of the base, you need to make sure you're understanding which of these is the base. It's not always the bottom, it's not always the top or the side, it's whatever is non-rectangular. Okay, now keep in mind here I said, well, all of these are rectangles, so it doesn't matter which is the base. Well, here I have two triangles. So the base is going to be the non-rectangular side. Okay, so in this case, we have these triangles. That's my base. That's my base. So if I'm calculating, let's go ahead, change this to purple. Okay, our surface area, I want 2 times the area of the base. Okay, well, if it's a triangle, remember, area of a triangle is 1/2. Okay, and we say base times height. Now keep in mind, I'm saying lowercase b because that represents a side. Okay, plus for the lateral area, the sides, lateral means sides. Okay, I want the perimeter of the base times the height. Okay, so let's go ahead and fill this in. 2 times 1/2. And here we will say 24 for the base of the triangle times the height of the triangle is 10. Now, one thing I should denote here, okay, this h and this h, they're different. So they're not equal to each other. So I should technically label this guy differently. So I'm going to put a little subscript b, so height of the base. Okay. So then here, then I have the perimeter of the base times the height of the prism. Okay. Now notice we are missing one side of the triangle here. Now luckily it's a right triangle, so I'm trying to find the hypotenuse. So if I want the hypotenuse, I know, okay, a squared plus b squared equals c squared, right? So we're gonna have to do a little more work there. So a squared plus b squared equals c squared. If I have 10 squared plus 24 squared equals c squared, if I were to calculate this out, I will let you do that on your own. Okay, work that out and just verify, but I will tell you right away that that comes out to be 26. That is actually one of our Pythagorean triples. It's a 5, 12, 13, just doubled, so 26. Okay, so I want the perimeter, so I add 26 plus 24 plus 10 gives me the perimeter of the base, which is 60, times the height, which is 20. Okay, so now I just gotta plop these into my calculator. Okay, I know the 2 times 1/2 gonna cancel out, so 24 times 10 gives me 240. And then 60 times 20 gives me 1200. Okay, so then I add those up. 1200 plus 240 gives me 1440. And again, our units inches squared. So those are my 2 surface areas. Okay. Again, if you just go through this, forget the equation, just look at the sides. You can calculate the area of a triangle. Do that twice. You can calculate the area of the rectangles. Do those however many rectangles there are. Now, one thing to keep in mind is, like in this rectangular prism, each of these lateral sides, they're not all the same. So you would need to do that guy. You could double that, but then you would also need the front here, which is the same as the back. So just be careful. Don't assume that they're all the same and just say times 4. Okay, you have to find at least the pairs. Okay, all right, so that's our prisms. Now, surface area of a right cylinder. So that's saying a cylinder that stands straight up. Think of a canned, think of a bottle. Okay, now same thing. If I unfold this to make a net, right, I'm going to have 2 circles, top and bottom, because those are our bases. And then if you think about a soup can label, if you were to unfold a soup can label, it just becomes a rectangle. Okay, so don't overthink that. So I have 2 circles and a rectangle, which again, we know the area formulas for. So I have our base up here. I have our base down here. Okay, so those are the area of the bases. So remember, that's pi r squared. So that's pi r squared. Okay. If I unfold that soup can label, the height of the rectangle is still the height of the cylinder. Now, one tricky thing here is, what is this bottom length of this rectangle? Notice that that green part is, if I just wrapped it back around, that is what we call the circumference. Now, how do we calculate circumference? Remember, that is 2 pi r. That's why we wanted to do the circles before this, because we're using some of those formulas here. Okay, so then if I put this all together, my surface area, okay, remember we had 2 times the area of the base plus the area of this rectangle. Okay, now I'm gonna change this and make it specific for a cylinder. So I have the area of the base, we know that's pi r squared. So instead of capital B, I'm just gonna make it simple, pi r squared. So I can just plug in the r, right? And then the area of the rectangle, well, that's length times width. Well, in this case, I have 2 pi r times the height. And there's our formula. Okay, but if, again, you break this down, we're really just looking at the area of the circles times 2, and then the area of the rectangle. Okay, so let's take that and apply it. So I want to find the surface area of this cylinder. Okay, again, if I unfold this, I have 2 circles. So I have 2 times pi r squared. And then I add to that the circumference times the height, because that's the rectangle. So 2 pi r times the height. Now notice there's just r's and h's, which I have. My radius is 3, my height is 9. So let's go ahead and plug those in. 2 pi times 3 squared plus 2 pi times 3 times 9. Okay, so let's go ahead and calculate this out. 2 pi times 9 plus, if I multiply this out, 54 pi. Okay, so 2 times 9 gives us 18 pi plus 54 pi. I can now add those because they're like terms. 18 plus 54, which gives me 72 pi. Now, if you remember back in our circles unit, that is what we call the exact answer. It's in terms of pi. Okay. For now, for us in our situation, let's just go ahead and calculate what that is. 72 times pi. Okay, and that will give us approximately 226.19, and again, we're in centimeters squared. All right. Both of those answers for us acceptable. I would just go ahead and get that decimal. Okay. Where did we go? Where did we go? Oh, I lost you. We'll bring you back. All right. All right. So that is our prisms and our cylinders. Okay, so here's just a quick little summary. If you want to just look at this slide, it gives you your equations. Remember our lateral area. Okay, so that's that top equation. But what we're focused on is surface area of a prism, surface area of your cylinder. Okay, so go ahead and take those. If that makes sense, then you can move on. If you're like, where did all this come from? Again, jump on to our office hours. Come and meet with us, and we will explain things. I know that was a little quick introduction to things, but again, hopefully this is review. You've done this before, so we're just refreshing. Okay. If you're ready, hop on to the next one. Again, we're going to talk about pyramids, cones, and spheres. More or less, we're just going to give you some equations to use and then apply those equations. All right. So long. Hopefully you're spending time with your ohana, which means family. Get it? Because we're in Hawaii. All right. Take care.